Last time we looked at sorting our data. This time we're going to look at searching for a piece of data. And there's two standard algorithms that you need to be aware of. The first one is called linear search, so as in a line of data. We're still using this concept of a list of data items, which means that we're using an array. Here, each of our numbers is just one item in the list, and we're going to search for the number 39. Now, in a linear search, we start at the first item in our list, and we check to see if we found our required number. So, is this 39? Well, no, it's not, it's 20. Then we move up one, and we go, well, is this 39? Nope. And then, is this 39? Well, yes, it is. We found our item, and then we can stop our algorithm. But what happens if this data is not in order? Well, at the moment, it could be in random order, and that's the nice thing about linear search, is that you can have a completely unsorted list and you can just step through each item. But I've only got 6 items here, which means that the worst case scenario is that I check 6 times. But if I had 1,000 items, worst case scenario is I have to check 1,000 times until I find the number. So let's speed it up again and put this item into order. Okay, what sorting algorithm did I just use? If you look back at the last video, what we just used there was an insertion sort. So we inserted the data at the right point. Now I have everything in order. If I have my linear search, I'd look at this one, then this one, then this one, then this one, and we're up to 4 checks already, then this one, then this one. So the complexity of this algorithm is the worst case scenario is that I would have to check for each item in the array. So if it has 6 items in it, the worst case scenario is that I need to make 6 checks. If it has 1,000 items, I may have to check 1,000 times. So alternatively, what I could do is I could use binary search. Now binary search will use a thing called divide and conquer. It will look for the biggest items. So here, my biggest possible item that I can look for is the middle point. Now the middle point here is right in the middle, but there's no number because I can have 3 this side and 3 this side. So again, we can use this arbitrary thing and look for the midpoint here. And we can say, I'm going to guess, so again, we're looking for 39. I found 3. Is it greater than 3? Well, yes, 39 is greater than 3. So what I can do is I can get rid of half my list. I have divided, conquered. It can only be in this half of the list. Now here, again, I find the midpoint. Now because it's an odd number, I can pick this one. So is my item that I'm looking for, so is 39 more than 20? Well, yes, it is. So again, more than half my list, gone. I only have 1 item left. Is it 39? Yes, it is. At this point, we've only asked 3 potential questions. Is it equal to or more than the midpoint? If you had 100 numbers, you could do this in 7 potential guesses or less. Try it in your class. Get somebody to guess a random number between 1 and 100 by aiming for the midpoint and asking, is it this or higher? When you only come down to 1, it has to be this. See if you can guess their random number.